What if I told you that particles can be in two places at once, or that just observing something changes its reality? Welcome to quantum mechanics, the science that governs the smallest parts of the universe and challenges everything we thought we knew about reality. Quantum mechanics is the branch of physics that deals with the behavior of matter and energy at the smallest scales: atoms, electrons, photons, and other subatomic particles. In our everyday world, things are predictable. A ball thrown in the air will follow a certain path. But in the quantum world, particles behave in ways that seem random, unpredictable, and downright weird. Quantum mechanics was born in the early 20th century when scientists realized that classical physics couldn't explain phenomena like the behavior of light or electrons in atoms. One of the first quantum discoveries was wave-particle duality. Light and matter can behave both like particles and waves. In the famous double-slit experiment, particles like electrons are fired at a screen through two slits. Instead of forming two piles, they create an interference pattern, like ripples in water, unless we observe them. If we watch, they suddenly act like particles again. It's as if the act of measurement collapses their wave-like behavior. This shocked scientists and led to deeper questions about reality. Superposition means a quantum particle can exist in multiple states at once. Think of a spinning coin. It's both heads and tails while in the air. In quantum terms, a particle like an electron can be in multiple positions, or an atom can be in multiple energy states until it's measured. This idea led to the famous thought experiment known as Schrödinger's cat, where a cat in a box is both alive and dead at the same time, until you open the box and look. Now, let's get weirder. Quantum entanglement is when two particles become linked, so that the state of one instantly affects the state of the other, even if they're light years apart. Einstein called this spooky action at a distance. Yet, it's real. Experiments have confirmed that entangled particles behave as one system, no matter the distance. This concept is at the heart of emerging technologies like quantum teleportation and quantum encryption. Unlike classical physics, quantum mechanics is probabilistic. You can't predict exactly where a particle will be, only the probability of finding it in a particular spot. This is captured in Heisenberg's uncertainty principle, the idea that you can't precisely know both a particle's position and momentum at the same time. In other words, the more you know about one, the less you know about the other. Quantum mechanics isn't just theoretical, it's behind the technology we use every day. Semiconductors power our computers and phones. Lasers rely on quantum principles. MRI machines, solar panels, even LEDs all work because of quantum physics. And now we're entering the next phase: quantum computing, quantum cryptography, and quantum sensors. Quantum mechanics challenges our basic assumptions about reality. Particles don't have fixed positions until measured. Observation affects outcomes. Cause and effect can get fuzzy at the quantum level. It forces us to ask, is reality deterministic, or is chance woven into the fabric of the universe? Understanding quantum mechanics isn't just about physics, it's about how we understand existence itself. Some of the greatest minds in history developed quantum theory. Max Planck discovered energy is quantized, the beginning of quantum theory. Niels Bohr developed the quantum model of the atom. Werner Heisenberg, uncertainty principle. Erwin Schrödinger, Schrödinger's equation and his famous cat. Albert Einstein. Though skeptical, he laid the groundwork for quantum theory with his work on the photoelectric effect. Quantum mechanics isn't just weird, it's real, it's tested, and it's essential to modern science. It shows us a world that's strange, unpredictable, and more interconnected than we ever imagined. Thanks for watching. If this blew your mind even a little, don't forget to like, subscribe, and tap the bell for more short, deep dives into fascinating science topics. Drop a comment if you have questions, or if you want to hear about quantum entanglement, teleportation, or quantum computing in future videos.